Okay, so in 1a, we're looking at y equaling 1 on the sine of x plus pi on 4. I'd like to consider what the graph of the sine of x plus pi on 4 looks like. So it's the sine of x that has been moved to the left, pi on 4. Therefore, if I was to break this up into pi, 2 pi, 3 pi, I now need to move all of this pi on 4, so I need to break these into pi on 4s. So that this point here now moves to there, to negative pi on 4. This point here now moves to there. This point here now moves to there. This point here now moves to there. And this point here now moves to there. This point here now moves to there. And we now end up with a curve that looks like that. If I was to consider what the y-intercept looks like, the sine of 0 plus pi on 4 is going to be the sine of pi on 4, which is root 2 on 2. So that point there is root 2 on 2, which means if I had to extend this line just to there, that's going to finish at pi on 2, root 2 on 2. Now, if I wanted to do 1 on all of this, therefore, my curve is going to have asymptotes at minus pi on 4, asymptotes at x equals 3 pi on 4, x equals 7 pi on 4. This point here, which is at 5 pi on 4, that's going to be at negative 1. And that won't change because negative 1, the reciprocal is still negative 1. So that's what my curve's going to look like. This point here, which is at pi on 4 and 1. However, this point here, which is root 2 on 2, when you do the reciprocal of root 2 on 2 and have 2 on root 2 and rationalize the denominator, you end up with root 2. So that's going to look like this, and that's going to be at root 2 and 0, which means we're going to finish the graph with the rest of that asymptote finishing at 2 pi and root 2. So that's going to be the graph of cosec of x plus pi on 4.